class, I'm going to talk to you a little bit about something called scientific notation. Now, if I took about a tablespoon of water, and I wanted to know how many molecules were in it, I'm going to get somewhere around this many molecules. Now that's a huge number, and it took a long time to write it. You definitely wouldn't want to write that huge of a number very often. So what we have is a shorthand way of writing huge numbers or very, very small numbers. That's called scientific notation. So on the other side here, we've got a little explanation and another example. So scientific notation is a shorter way to write and express very large or very small numbers. There's another example here. If I were talking about the mass of a proton, which we'll talk about what protons are later, it's a part of the atom. If I wanted to know what the mass of a proton is, it's extremely small. It's 0.000000000000000, and so on. I could keep going on through that. But it's a very small number of kilograms. Now, if I wanted to write that in scientific notation, I could do that. I could call this 1.6726 times 10 to the negative, and let's see, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27 kilograms. Okay, same number. I just wrote it a different way. Now, if you didn't quite follow how I did that just now, that's okay. The point of this was to give you an example, but now we're going to talk about how to write scientific notation. So regular notation, if we want to turn regular notation, which is a normally written number, into scientific notation, these are the directions we're going to follow. Move the decimal point so that you have one non-zero number in front of the decimal point. In front means to the left. So when I say in front, I mean to the left. So there's only one number on the left of the decimal point that is not a zero. If the original number is smaller than 1, the exponent will be negative. So this number here is definitely smaller than 1. So the exponent has to be negative. That's how I knew that was a negative exponent, not positive. If the original number, the regular number, is greater than 10, the exponent has to be positive. Let me flip my paper over real quick. That number is very big. It's definitely more than 10. If it's more than 10, my exponent is positive. So this one, and I'm not going to go through counting the zeros for you, this one I just happen to know is 6.02 times 10 to the 23rd power. Okay, but it's a positive number because this is larger than 10. Okay. Let's look at the example down here. Before we even get started, I would try to decide, is this going to be a negative or a positive exponent? Looking at this one, it's smaller than 1, so it's going to be a negative exponent. Now I just need to count how many spaces do I have to move the decimal to get it right after the first non-zero. Well, my first non-zero is 4, so I need to move the decimal right there, right after the first non-zero. So I'm going to go 1, 2, 3, 4, 5. I moved it 5 spaces. 4.78, putting the decimal in the right place. I moved it 5 spaces, and because this is smaller than 1, it's a negative power. So it's 4.78 times 10 to the negative 5th. And it's always times 10, because we're just moving the decimal. Times 10 to some power. So the notation will always be some number times 10 raised to some power. All right, this one, is it smaller than 1 or is it bigger than 10? Well, it's bigger than 10. Okay, so I want to move my decimal to where it's right after the first non-zero. The first non-zero, as you read a page, would be 2. So I want my decimal right here. Since I didn't show the decimal, I can assume the decimal's at the end of the number. I'm just going to move it back. 1, 2, 3, 4, 5, 6, 7 spaces. So I have 2.468 times 10 to the, did I just say 7 to 7, 10 to the 7th power. Is it positive or negative 7? Well, this number was larger than 10, so that makes that a positive exponent. Now, what if it's not larger than 10, but it's not smaller than 1? Like this number, 2.31. Well, think about it this way. Do I need to move the decimal to get it right after the first non-zero? I don't have to move it at all. So how many spaces did I move it? I moved it 0 spaces. So if I have to write this in scientific notation, this is how I would do it. It doesn't make a lot of sense to do this usually, but if you have to write it in scientific notation for some reason, this would be 2.31 times 10. We still got to put that 10, but I didn't move it any spaces, so it'd be 10 to the 0 power. All right, let's learn how to do it the opposite direction. Going from scientific notation to regular notation. Sometimes we're going to give it to you in scientific notation. You have to turn it into regular notation. So it gives you some instructions here. If the exponent is positive, move the decimal point so you would have a large number at the end. So we're going to turn the normal number into a large number. We're going to move it to the right so the number gets bigger. If the exponent is negative, move the decimal point so that you would have a small number at the end, smaller than 1. So the decimal point would move to the left to make the number smaller. I have 4.5 times 10 to the negative 4th. That's a negative exponent, so which way should I move my decimal? I'm going to move it left. I want to make this number smaller, so we're going to move 1, 2, 3, 4, and every bump gets a 0 unless there's already a number there. So it's going to be 0 point, and you don't have to put a 0 at the beginning if you want to just make it point. But then we've got to have 3 zeros, then 4, 5. 0, 0, 0, 4, 5. Okay, and then this. This is 1.23456 times 10 to the 3rd. It's a positive exponent, so I need to move the decimal to the right. I want to make this number bigger. 3 spaces to the right. 1, 2, 3. Okay, so I'm just going to write 1, 2, 3, 4, and the decimal's right there. 0.56. In this case, I didn't need to add any zeros. I just moved the decimal, and that was all. Okay. Now, a lot of times you're going to be doing calculations that involve significant figures. This is very important. You're going to use this all year long. It's called the E button. We'll use the E button a lot. Now, if you're using a graphing calculator or using the one on your Chromebook that looks just like this, I'm going to show you where the E button is. If you have a scientific calculator similar to this one, I'll show you where it is on that as well. If you have a different scientific calculator, check with your teacher and they can try to help you find the E button. But we want to know where it is, okay? The E button on this is the second button, which is that, usually it's a blue button or a yellow button, top left-hand corner that says second. You're going to push that and then you push the comma. See the blue EE above it? Capital E, capital E. This is different than the lowercase e. You need to make sure you're using that E button in your calculator. Second, comma on these. That's the E button. So where is it? Second, comma. Okay, I'm just putting the comma in parentheses. So you're going to do second and then comma. We'll talk about how to use it too. If I want to put this in the calculator, 5.67 times 10 to the fourth, the way that I write it is 5.67 E4. So I'm going to use that EE button and then the number 4. Write this down. E is the same thing as times 10 to the power. Well, why wouldn't I just write times 10 to the power then? Doesn't that kind of make more sense? Well, the problem is if you write times 10 to the power, it will mess up your order of operations. Do you remember PEMDAS? Your calculator doesn't always know how to do order of operations with scientific notation. So if we're doing scientific notation, it's important that you use the E button so it doesn't default to do PEMDAS wrong, okay? Don't worry about it too much, just make sure you always use that E button when we're talking about scientific notation. All right, this one would be 4.32 E negative 6. And by the way, when we use the negative button, I want you to always make sure that we're using the negative that's in parentheses, which is right below the 3 on your calculator, this button right here. If you type in that button, the minus sign, instead of the negative button, you're going to get an error code in your calculator and it will never work. All right, do a couple calculations down here. I want you to take a minute, pause this video, and try these using the E button that we just talked about and make sure that you get the same answer that I do. The first one, we're going to type in 4.863 times 10 to the third, that's second, comma, 3, plus 4.72 second, comma, 2 equals, and you should get 5,335. That's the answer it should give you. 5,335. Now let's try the next one. 8.467 times 10 to the negative third is second, comma, and then remember that negative button, negative 3. And that division sign divided by 6.13 second, comma, negative 24. Second comma means times 10 to the power. So I'm just going to replace the whole times 10 to the power and only write E24. Answer I get on this is it's a lot of numbers, okay? I'm just going to keep the first, I don't know, let's keep the first 4 numbers, okay? 1.381, 1.381, but when you're working with calculations in chemistry, I always want you to check the end of the number. Do you see right here where it's got the E21? Okay? So the calculator, I'll write down exactly what it says. 1.381239804 E21. What that means is this tells us it's times 10 to the power of 21. So my actual answer, and I'm going to round it to, let's call it 2 decimals, okay? 1.38 times 10 to the power of 21. Okay? And you want to always make sure that you write your E notation, write it with a times 10 instead, okay? In your calculator, we use the E, but on paper, you need to make sure you're writing times 10 to the power.